Good morning, everyone. This is Henry from A-STEM Tutoring once again, attempting to serve as the wise old sensei. I may be old, not sure if I'm wise enough, but I will try. Today's lesson is another one about basic electronics, and today we will discuss how to combine capacitors, both in parallel and in series. So let's go over to our handy-dandy whiteboard here. So for this first case of two capacitors in parallel, there's a voltage source applied across them. You'll notice that they're in parallel because the same voltage is dropping across both capacitors. So let's say the first capacitor over here is 10 microfarads. Oops. And let's say the capacitor over here is 20 microfarads. If we wanted to replace both capacitors with a single equivalent capacitor, we could use this formula here. Capacitor that's equivalent, CEQ, the equivalent capacitance, equals the sum of the two capacitances in parallel. So that would be 10 plus 20, which would give us 30 microfarads. So if we wanted to, we could replace both capacitors in parallel with a single capacitor of equal to a value 30 microfarads, and the circuit would perform the same from the perspective of the outside world anyway. Now, for capacitors in series, it gets a little bit harder. Remember that capacitors in parallel combine like resistors in series, and capacitors in series combine like resistors in parallel. So let's say we have two capacitors here. Let's make them again 10 microfarads and 20 microfarads. If we want to replace both capacitors with a single equivalent capacitor, we could use this formula: 1 over the equivalent capacitance, the reciprocal of the equivalent capacitance, equals the sum of the reciprocals of the individual capacitors that are placed in series. So 1 over 10 plus 1 over 20. We can cross multiply to get a common denominator, which would mean this equals 20 plus 10 over 20 times 10, which means that the actual equivalent capacitance equals 20 times 10 over 20 plus 10. And again, the units are microfarads. Now, I left it in this form to illustrate something important. When you have two capacitors in series, the equivalent capacitance will be equal to the product of the capacitances divided by the sum of the capacitances. And if they happen to both be the same value, then the equivalent capacitance will be half the capacitance of an individual capacitor if it's two equal value capacitors placed in series, just like if you had two resistors placed in parallel. So this has been a quick discussion with a simple example of how to combine capacitors both in series and in parallel. Basic rule to remember is that capacitors in parallel combine like resistors in series, and capacitors in series combine like resistors in parallel. This concludes today's lesson. If you'd like to learn more, I'm available for hire as a private tutor. You can see my contact information in red at the top center. The first 1 hour lesson is free for new students. Try before you buy. You take no financial risk. The burden of proof is entirely on me to demonstrate outstanding value in helping you succeed in your classes. And as a thank you for watching all the way to the end of today's video, if you mention the code free book when you contact me at our initial lesson, I will give you a free copy of my book, Smart Suggestions for Student Success. I wrote this book in an effort to help students, in particular high school students and college students, succeed in school, work, and in life. Thanks for watching. Have a good day.